Very good morning, students. Welcome back to online session on programming for problem solving course. In our previous session, we have completed all the program development steps. Like we started with the structure charts, we discussed algorithms, we discussed pseudocode, we discussed flow charts, the different symbols associated with flow charts. Everything we have completed in our previous sessions. In today's session, we'll be getting into the C programming concepts or C language concepts. So let us quickly start the discussion about the history of C language or the introduction to the C language. So here we discuss how the evolution of this C language has been done over the years. I mean, what makes the developers to develop this C language, what initial inventions have been done into programming languages, all those things we discuss into the history of C language. Okay, step by step we'll do that. So history of C language, as we know, the C language is a structured programming language as well as it is a high level programming language. The reason for calling the C language as a high level programming language is that it gives the flexibility to the programmer to focus more on the problem in hand rather than focusing on the machine hardware, computer hardware. So as we might have discussed in the language evolution, over there we discussed three different types of programming languages, that is machine language, symbolic language and high level programming language. So we said in machine language the entire concentration of the programmer will be on the machine. So according to the machine only, the programmer is going to write the instructions in machine language, machine programming language. Then we have the symbolic language where we used different symbols to write the instructions or statements in programming language. And finally, we have the high level programming language where we are going to use the normal English like statements to write the programming language instructions. So here in C language we'll do the same. In C language also we are going to use more or less like English like statements in order to write the program code. So when we exactly do that, you will understand. Okay, why we call the C language as a high level programming language, in the sense it gives the flexibility to the programmer, so where the programmer is completely free of worrying about the machine hardware. He no need to worry about the machine hardware, rather he can only focus on the problem which he is having in hand, and how he is going to solve that problem. he can he can merely focus on that. Okay, so the reason for considering the C language as high level language is that one only. So the C language, another reason for calling C language as high level language is that it is completely machine independent. Okay, the concept of machine independentness, it is also we discussed when we studied about different types of programming languages. Okay, we said machine languages, they are completely dependent on machine, whereas high level languages, they are independent of the machines. Independent of the machine in the sense you can write the instructions in one computer and you can transfer those instructions into another computer and you can execute those statements into another computers. Or simply we can say the object code what we are going to get when we execute the C program, that object code you can carry from one machine to another machine and you can execute that object code in other machine and you can get the output. So this is the concept of machine independentness. So writing once and executing many places, or executing in different places. So that is the concept of machine independentness. And C, being a high level language, it also supports the concept of machine independentness. Okay, so this is the reason why the many software developers use this C language to develop their applications. Okay, So they will write the application program, or they will write the program code on one machine, and when you go to a different machine, there you don't need to write the complete code once again. Rather, what we do, we simply copy the object code and we run that object code over there to get the output. So this is the concept of machine independentness. Because of this also, we call the C language as a high level programming language. And this C language, it is derived from a programming language called Algol. This is the first block structured programming language, and your C is also one such language. It is also a structured programming language. Here only we are saying that in the first instruction, I mean in the first statement only, we are saying that C language is a structured programming language. Structured programming language in the sense we follow a kind of structure when we write the program. Okay, so as it is derived, as C language is derived from Algol, this Algol, it is also a structured programming language, and it follows the block structure. Okay, so when we write the programs in Algol programming language, we divide the program into blocks, different blocks. In that same way, when you write the program in C language, we also divide the C language into different modules. Okay, different modules. That is the reason we call the C language as a structured programming language. You cannot write these statements, you cannot write the irrelevant statements into your C program. Definitely you need to follow a proper structure when you are writing the C language program. Okay, so this Algol, when we are talking about this Algol, it was introduced in the year 1960s. Okay, there is no specific year they have specified, but it was introduced in the year in the early 1960s. Okay, this make the way to the development of structured programming concept, as this Algol is following the block structure. So from here onwards, whatever programming languages they have developed, they try to follow a structured concept. Okay, so because of that reason, as C language is also derived from Algol, this C language, it will also follow a structured concept. Okay, so after that derivation, I mean after deriving the C language, I mean why this structured concept got popularity in the sense, uh, during 1960s only, in the year 1966, it is specifically mentioned in the year 1966, there are two computer scientists. Their names are Corrado Bohum. Here you can read that name, and Giuseppe Jacopini. Okay, these two, they are basically computer scientists. He is the first one, and here he is the second one. These two are basically the computer scientists. What they have done means they published a paper, okay, by giving support to this structured programming concept. They felt that this structured programming will make a new evolution in the programming era. So what they have done, they published a paper by supporting this structured programming concept. And when they have done this, in the sense, in the year 1966. So this is, I mean, because of this paper, I mean, because of these two scientists contribution, again the structured programming concept got the popularity in the market. So after that, what has happened, another programming scientist, another computer scientist, his name is Edgar Distra. It is very difficult to pronounce these names. Edgar Dijkstra, okay, wrote a letter to the editor of the communication, ACM, Association of Computing Machinery, and he also supported the concept of structured programming. And because of this also, many developers, I mean many programming language developers, they shifted their attention to this structured programming concept. Okay, because of their effort only, this structured programming concept got the popularity in the market. Okay, so the first reason, because the C language was what we call derived from Algol, C language followed the structured programming concept. The second reason is because these two scientists, they gave the popularity to this structured programming concept. Okay, then in the year 1967, what has happened? Martin Richards, okay, he's also a programming language developer. What he has done means he developed a new programming language called Basic Combined Programming Language, in short BCPL. Okay, in the year 1967, Martin Richard, he has developed a language called Basic Combined Programming Language, and it is also derived from ALGOL. Okay, this BCPL, it is also derived from ALGOL, and this BCPL is also a structured programming language only. Okay, so then in the year 1970, okay, similar language, okay, similar to the BCPL language, another language is developed, and they call this language as the B language. Okay, and who developed this B language? In the sense, Ken Thompson, the scientist name or the developer name is Ken Thompson. What he has done, he developed a language with the name B language in the year 1970. Okay, and this B language was used to develop the Unix operating system. I mean, many of you might be aware of this Unix programming, I mean operating system. It is a network operating system, Unix. So this Unix, this entire operating system is developed in B language. Okay, then finally, I mean, all these things, they just gave the way to the development of C language. So finally, what has happened in the year 1972, Dennis Ritchie, okay, he developed the C language by combining many concepts. I mean, what he has done, he not only took the concepts from ALGOL, BCPL, B, I mean, and added many different concepts to these three, and finally he developed the C language. C language in the year 1972. Okay, and the person name, the scientist name who developed the C language is Dennis Ritchie. Remember this name. Okay, when he has developed in the year 1972. Okay, this is the basic version. This is the first version of C language, and they called this first version, or the initial version, or the basic version, as traditional C. Okay, what the Dennis Ritchie team has developed at Bell Laboratories, they called that language as traditional C language. Okay, uh, yes. I mean, who called this language as a traditional C? In the sense, the team of people, the Dennis Ritchie team only called this language as traditional C in their book. I mean, the book name is Brain W. Kernighan and Dennis Ritchie in the year 1978. When they have popularized or published this book, in the sense, in the year 1978, and the book name is Brain W. Kernighan and Dennis Ritchie. Okay, so this is the first version, or the traditional version of C developed by Dennis Ritchie. So from okay, once again we quickly overview the developments so far, whatever we have discussed. So C is a high level language, it is a structured language, and it is machine independent language, and it was derived from ALGOL. Not only ALGOL, it was also derived from, it took few of the concepts from BCPL and also from B. So now you might have understood why they have given the name C to this programming language, why they have called this C language, because there was already a language with name ALGOL. So you can call, you can consider this ALGOL language as A language, because A is there, isn't it? ALGOL. Then from ALGOL we got BCPL, and from BCPL we got B. Okay, here we have the language B language. Okay, so later, because they developed by following this ALGOL, BCPL and B concepts, and they developed this new language, so they named this language as C language. That's the reason they have given the name C. There is no other reason for calling this C language as C language. Okay, already we have A language, we have B language. So later they have added some more concepts, and they developed this new language, and they call this new language as C language. Okay, so This traditional version they have developed in the year 1972, and they have popularized in the year 1978 it as a traditional C. This is not the end in the development process. Okay, later, after 1972 also, a lot of advancements have been done into this C language. And what are those advancements? In the sense, in the year 1983, the American National Standards Organization, or American National Standards Institution, simply we call it as ANSI, ANSI, ANSI. These people, they have adopted, or they have given the approval to this traditional C. Okay, when they have given in the year 1983. Okay, so they made it as a standard in the year 1983, but the approval has been given in the year 1989. Okay, so this version of C they call it as C89. Okay, later in the year 1990, the International Standards Organization ISO has also adopted the standard given by the ANSI people. So in the year 1983, they have given the standard. ANSI people, American National Standards Institution people, they have given a standard to this one. Okay, that standard it got approved in the year 1989, and later in the year 1990, the International Standards Organization ISO has adopted this ANSI standard, and this version of C they called it as C89. Remember this name, C89, because the ANSI people as well as ISO people has approved this one. It is also got popularity, and they called it as C89. Okay, some more changes have been done. I mean, from traditional, we have now traditional when in the year 1972 by Dennis Ritchie and team. Then we got C89 when it is. Okay, standard is being given in the year 83 and approval got in 89. That's the reason we call it as C89. And who gave these standard? Two organizations, ANSI as well as ISO. These two organizations have given the standards. Okay, standard has been given in the year 83 and approval has been got in the year 89. So we called it as C89. Later, some more changes have been done to the C89, and this version of C they called it as C95. And when those changes, minor changes, when those minor changes have been done in the sense in the year 95, 1995. So this version of C they called it as C95. Remember this one. From traditional we got C89. Now we have C95. So some more major changes have been done to this C95, and we called that the new version of C as C99, because when those changes have been done in the sense in the year 1999, in the year 1999, significant changes were made to C85. This version of C they referred as C99. And what are those changes? In the sense, they have added some extension to the character type support to support the non-English characters as well. I mean, those changes, I mean, 6 changes have been made to C85. They have they kept those 6 changes over here. The first one, extension to the character type, and they another new data type, boolean type, has been added, and extension to the integer type, and inclusion of type def and first statement, addition of imaginary and complex types, and inclusion of multi-line comments. Okay, sorry, inclusion of line comment. Okay, previously these sort of things were not there in C85. If you go and if you see, these sort of things were not there. They have added all these things to C85, and they called that new C as C99. And when it has been done in the sense in the year 1999. So this is the final version. I mean, after 1999 also we have lot many years, around 2 decades if we consider, isn't it? Around 2 decades, from 1999 to 2009, and from 2009 to 2019, it is almost like 20 plus years, 2 decades. So in this 2 decades, a lot of changes have been done. So those changes are not for our consideration, not under our curriculum. So we start our discussion up to C99 only. Okay, we discuss up to C99 only. So I think all of you hopefully got an idea about the history of C, how the traditional C have been developed from Algol, from BCPL, from B language, adding some more concepts and developing a new programming language and naming it as the traditional C in the year 1972. Later in the year 83, how ANSI and ISO people have given the standard to the C language and how it got approved in the year 89, and so they called this new approved C language as C89. And some more changes, minor changes have been done to C89 in the year 95 and they called it as C95. Some more significant changes have been made to the C95 and in the year 99 and they called it as C99. Okay, and what are those changes? I mean, in the sense 1 2 3 4 5 6, these 6 changes have been made to the C85 to make it as a new C known as C99. Hopefully you understood this history. So quickly get into the, I mean, this is the taxonomy of C language. I mean, how everything has been done. See, you can see from Algol. So this particular path we need to focus and we need to discuss this particular path. So from Algol we got BCPL, then we have B, then we have traditional C in the year 1972, then we have ANSI and ISO standard, that is C95, C89 as well as C99, these three C's. Okay, so not only this version of programming languages, from Algol we have Algol 68, Algol W, and from Algol Pascal also got derived, and Modula 2, Modula 3. All these things are different versions of programming languages. Those are not of our concern. Okay, if you have interest, you can go and you can study about them as well. Okay, so quickly, the next concept in C language, that is comments. So comments, in every program we put these comments, and these comments are basically helpful in documenting the code. As you know, when you're writing C language program, it is a different language. So when you approach a customer or when you work in a company, so a lot of different people will get involved in the project development or in application program development. So if you write the logic in C language, there are people in your team who don't understand C language. So how you will give the clarity about the code to them? So if you give the C code to me, because I know how a C program will work, I mean how we write a C program, what statements we write, what statements we put in a C language, in a C program, all those things are quite familiar to me. So I can understand the program written in C language. But if you give that same program to a third party person who don't have any knowledge about C, what he will do with that code? He will not understand anything, isn't it? He will not understand because he don't have the knowledge of C, so he don't understand anything from that code. So there comes the importance of these comments. So with the comments, a lame person can also understand what exactly you are doing inside your application program. So in that way, these comments are going to help us. In that way, these comments are going to helpful in documenting the code. Documenting the code is nothing but writing the general instructions about the C programming code. Writing the general English-like theory about the C programming code. Okay. So comments are helpful in documenting the code. Okay. Comments improves the readability and understanding of the code. As I mentioned just now, even a lame person can also understand if you do proper commenting inside your C language code. Okay, so we are not going to write the comments, or we are not going to document the code in a separate file or in on a paper. Okay, so generally we put the comments within the program code itself, within the actual program code itself. Okay, remember this one. Then the compiler the job. I mean, how the compiler, I mean, basically whenever we write a C program, if you put some unnecessary stuff inside a C program, your compiler will generate errors. Your compiler will give issues to us. We call those issues as errors. So how a compiler will deal with these comments, in the sense it will simply ignores them. It will not consider those comments as part of your C program. It will simply ignores. Okay, and when it translates the program into executable code, it will not touch those comments. It will simply ignores those comments. Okay, how these comments will work, what the role of these comments in our program, when we practically do the programming, there you will understand. So the comments, they are of two types, block comments and line comments. Okay, so generally block comments will span more than one line, and line comments, they will span only one single line. Okay, so block comments means you can put uh, several lines of comments inside a block comment, and in order to do the block commenting, you have to use these two tokens. This is the start token and this is the end token. This is the start token and this is the end token. These two tokens will be used in order to do the block comment, in order to put the block comment inside your C program. So block comment will span, as we just discussed, block comment will span several lines. Several lines in the sense more than one line. Okay, so whatever lines of code you want to put inside the block comment, you have to put all that code between these two symbols. As you can see here, I have given the example. This is the opening of the block comment and this is the closing or ending of the block comment. And here between these two symbols, how many lines of code we kept? 3 lines of description we kept. 1, 2, 3. So something like this, you can put the block comment inside your C program. Then we have the line comment, which will span only one line, and the token for that line comment is 2/. So something like this, you can use 2/ as the start token for the line comment, and there is no end token. Wherever you are ending the line, there only the line comment will end. There is no end token. There is no end token for the line comment. The end of line token itself acts as a end token. The end of line token itself acts as a end token for line comment. Remember this one. Block comment will take several lines of code. Line comment will take only one line of code. And for block comment, we have two different symbols, one to start the block comment and one to end the block comment. And whatever lines of code you want to put in a block comment, you have to put between those two symbols only, between those two tokens only. But whereas line comment, it will have only the start token, it will not have any associated end token. The end of line token itself act like a end token for the line comment. So here I have given the best examples for both the block comment as well as the line comment. There is another concept like a nesting of comments. How you can nest the comments one into another. Like we said, we have two different types of comments, that is block comment and line comment. So you can nest a line comment within a line comment, you can nest a block comment within a line comment, and you can also nest a line comment within a block comment, and you can also nest a block comment within a block comment. The concept is very simple. See, nesting of line comment within a line comment, it will not generate any errors. See, like this line comment I have started, here I am writing some code, then another line comment I am starting, and again I am writing some code, and I am pressing the enter key over here. So it is a nesting of line comment within a line comment. Next thing is nesting line comment within a block comment. So block comment, how we will start? Like this, we start several lines of code, then I am writing line comment, then I am ending the block comment. So this will also not generate any issues. So the first two will not generate any issues. Okay, coming to the third one, nesting block comment within a line comment. So of course it will generate errors, it will generate issues. So one by one we will see in detail. So the first one is a nesting line comment within a block comment. So as you can see here, I have started one line comment over here and I'm nesting another line comment into the already existing line comment. So doing so will not generate any error because this token will be ignored by the compiler as part of the comment only. It will not be considered as a starting of another line comment. It will be simply ignored. It will be simply ignored, or it will be considered as a part of the line comment only. Okay, so it will not generate any errors. No error condition, as you can read the last statement, no error condition. So the next thing we have nesting of line comment within a block comment. So I have started the block comment over here. Okay, this is the starting of block comment and this is the ending of block comment, and here I kept the 3 lines of comments. Okay, and here I am starting another line comment. So this will doing like this will also not generate any kind of issues. Remember this one, no error condition. Here also no error condition. Coming to the third one, that is nesting of block comment within a line comment. So here I have started the line comment and here I am starting the block comment. So where exactly this line comment will end? Here the line comment will end, and the token, the start token which you kept for the block comment, it will be ignored by the compiler, and this extra lines what you are keeping over here will generate issue, will generate error. Okay, these 2 lines will generate errors because your compiler will not consider this as a part of comment. Your compiler will consider them as something extra into the program which is not following the C language syntax. So definitely whenever you write the statements which are not following the C language syntax, means ultimately your compiler will raise issues. So here you will get error. So unless you do it practically, you will not understand it thoroughly. Try to remember the stuff. Okay, try to remember the stuff as much as possible. Once we do the stuff practically, you will understand everything, believe me. So the next thing, nesting of block comment within a block comment. This will also not generate any kind of error. Okay, see here. So when I'm starting the, yes, this will generate issue. This will generate issue. Sorry, I beg your pardon. So over here we have started the block comment, and when it sees the starting of block comment, the compiler starts ignoring the stuff. Your compiler will start ignoring the stuff. Till what extent it will ignore the stuff? In the sense, until and unless it sees an end token for the block comment. Until and unless it sees the end token for a block comment. So from here it will ignore all these things. This entire thing will be ignored. This symbol also will get ignored by the compiler. This will also be ignored by the compiler. This will also be ignored by the compiler. When it sees this end token, it will consider this end token as a pair to this start token. To this start token. And whatever we are writing, this extra thing, it is not following C language syntax. Okay, so it will generate error condition. Left alone and will generate error condition. So here, from here to here, whatever we kept, this will generate error condition. So the first 2 cases in our 4 different things, the first 2 cases will not generate any issues and the rest 2 cases will generate issues. So this is about nesting of the comments. So next thing we have in our C language is the C's character set. So this C's character set will also be considered like an alphabet to C language. So whenever we are learning or studying about English language, we are going to have alphabet to the English language, like all A, B, C, D up to Z, 26 characters in English language. We call them as English alphabet. So here also in C language, when you write the C programs, when you write the instructions to the computer in C program, in C language, what are all the symbols, what are all the characters we use, we call them as C's alphabet, or in short we call it as C's character set. So set of characters, all the characters which are helpful in writing the C program. Okay, so A program is a set of instructions that when executed generates an output. The data input that is processed by a program consists of various characters and symbols. Basically, whenever you write a statement, whenever you write an instruction into your C program, that instruction consists of different symbols or different characters. Same thing when you do in your English language. So here I have written a statement. The output generated is also a combination of characters and symbols. So this particular thing from here to here, it is an English statement. And how I wrote this English statement by using all English characters. Here I'm using all the English characters to write this English statements, and it is giving a proper meaning to me. In that same way, when you write a program statement, a C language statement, there also you are going to use different characters, and we call all those characters, all those set of characters as C's character set. Only the characters given inside the C's character set are allowed when you write the C instructions or when you write the C programs. Okay. So what are those different characters that are allowed when writing the C programs? In the sense, is there any standardization, is there any standard has been made for that? In the sense, yes, of course. So we have in C's characters, we have four different types of symbols, and there are other symbols also we have. So first, let us quickly study about these things. We have letters, we have numbers, and we have some special characters, and we also have the white spaces. Okay, these four types of characters we use, these four types of character sets we use when we write a C program. Or we can say C's character set is divided into four different types: letters, numbers, and special characters, white spaces. White spaces or blank spaces. So what are letters in the sense? See, letters, all uppercase and lowercase letters from your English. So whatever English characters you have on your keyboard, all those English characters, both in uppercase, capitals, and lowercase, the small letters, both you can use when you're writing the C program. Okay. The next thing, the numbers. Numbers, whatever numbers you have on your keyboard, that is 0 to 9, digits 0 to 9, those you can use inside your um, C program. Then white spaces, the blank spaces, spaces which you give between the words, the spaces which you give between the letters, uh, the blank spaces, that also you can use inside your C program. And a new line character, whenever you are reaching the end of the line, you are hitting the enter key. So how that enter key will be treated, how that enter key will be considered inside your C program, in the sense it will be considered like a new line character, a special type of character, a new line character. And carriage return and horizontal tab, all these things are also considered as the C's character set. Okay. Then we have some special characters, not only those letters, digits, and white spaces. We also have some special characters like uh, all the special symbols like comma, dot, semicolon, colon, question mark, single quotes, double quotes, exclamatory marks, vertical bars, forward and backward slash, tilde symbol, underscore symbol, dollar symbol, percentile, and different brackets, curly brackets, square brackets, parenthesis, your ampersand symbols, and all the operator symbols like plus, minus, multiplication, division, less than, greater than, pound symbol, hash symbol. All these special characters are also allowed. So not I mean, when I'm saying allowed, you simply can't use these characters without their requirement or without their necessity. There is a standard, there is a standard procedure to use all these characters, all these special symbols, special characters into your C program. So when you understand the meaning of all these characters, then only you will be able to use these characters into your C program. So of course, believe me, when you start doing the stuff, it will become more easy for you. Instead of reading them, instead of practicing them theoretically, it is better to do practically. when you start writing, when you start narrating the programs in C language, slowly you will start learning all these things. In a single shot or in a single lecture, in a single instance, it is not at all possible to explain all these things. So we have to practice. We will practice throughout this semester, and believe me, you will become uh, completely aware of all these things. Okay, this is about the C's character set. Inside C's character set, we have four different things: the letters, uppercase and lowercase letters, then digits, numbers, the 0 to 9 digits, then we have blank spaces, white spaces, that is nothing but the spaces which we give between the lines, between the letters, and we also have the special characters, and here is the table where you can see all the special characters that are allowed inside the C language. So one small statement I want to make over here is that simply you can remember whatever characters you see on the keyboard, all those characters, they're having some special meaning in C language, and you can use them as part of narrating the programs. Okay, so the next thing, we have the escape sequences, and these escape sequences, it is not a single character, rather it is a combination of characters. Okay, these special meaning characters, we can say. So an escape sequence in C language is a sequence of characters. When I'm saying sequence, it is not a single, rather it is a combination of characters that doesn't represent itself when used inside string, literal, or character. See, in order to use this, when we use this special escape sequences in our program, on your output you will get some formatting. Okay, they will not represent as it, they will not come as it is on the output screen. Rather, what they will do, they will give some formatting on the output screen. So these escape sequences, we have a list of escape sequences, and all the escape sequences, they start with a backslash. So this particular symbol you need to remember as a backslash, and this backslash is used when we are typing or when we are using a special escape sequence in our program. So this special sequence or escape sequence, it is having some special meaning in our program. So the meaning you can understand over here. See, slash a, it will, when you use this slash a into the program, and if you have a proper what we call a basic speaker connected to your computer, it will give an alarming sound, a beep sound. A particular statement got executed, you reached a particular statement. In order to understand that one, you can put this alarm sound or beep sound. So to put that beep sound into your program or into your instruction, you simply put backslash a. Okay, simply put backslash a. So when the compiler or when the program control reaches this backslash a, it will simply generate a sound, an alarm sound. Then uh, to use a backspace into your instruction, use backslash b. Okay, form feed, back new line character, carriage return, horizontal tab, vertical tab. This is to get a backslash, this is to get a colon, single colon, double colon, this is to get a question mark, this is to get octal number, hexadecimal number, and null character. All these things we use with the help of these escape sequences in order to get these special features into our program, or in order to format the output on your output screen. We use these escape sequences. Remember this one. So the next one, we have the concept of identifiers. So today we will complete identifiers and keywords, and I will give an idea about data types and variables in my next lecture. Okay, so the identifiers. So the next important concept, or we can say it is one of the very important concept, identifiers. Many times they ask, in your annual exams, they will ask this concept for 2 marks. What are identifiers, and what are the rules for generating identifiers? So see, in any language, whether you go to Urdu, whether you go to English, whether you go to Tamil, Telugu, whatever language you talk about, uh, the first primary thing is we need to learn the character set of that language that we have already learned. Character set in the sense what type of symbols are allowed into that language, isn't it? So if you go to English, all English alphabets are allowed into the English program, I mean English language. So when we are talking about the C language, we discussed what symbols are allowed into C language that we have discussed. Like we said, all the English alphabets are allowed, the digits are allowed 0 to 9, special characters are allowed, and white spaces are allowed, we said. So that is studying about the character set or the alphabet. After learning the alphabets, what we do generally, what we do in any language, we start learning the objects, isn't it? Object names we start learning. Like we have water. What do we call that water in Telugu? What do we call that water into Hindi? Like that. We have let us assume we have a classroom. So what do we call a classroom in Telugu? What do we call a classroom in Tamil? Likewise, we start learning the names, isn't it? The names. How do we call different objects which are surrounded us in whatever new language you're learning? So here also we are learning a new language, C language. So how do we name the objects? In C language, how do we name the objects? So in order to name the objects, we use nouns in English, isn't it? We use nouns in English in order to name the objects. Okay. So same way, in order to name the objects in C language, we use identifiers. So we can say identifiers are similar to nouns in English language. Hope you understood. So in any language, we definitely need to know the names of different objects which are surrounded us, because in order to communicate using that language, definitely we need to know the names of each and every object. Then only it is possible for us to frame the sentences in that language. In that same manner, when you are learning a C language and when you want to write the instructions into C language, definitely you need to know how you can name different objects in C language. So naming the objects, we use nouns. In English, in that same way, naming the objects in C language, we use identifiers. So identifiers are similar to nouns. Remember this one. So identifiers are used to name data and other objects in the program. In C program, how we use the identifiers in order to name the data as well as other objects in a program. So they are, I mean, identifiers, it is similar to nouns in natural languages. In natural languages, we are having nouns. In C language, we are having identifiers. That's it. So when objects are declared in computer program, they will be stored at unique memory location. These memory locations will have unique addresses to represent. See, whenever we declare a variable, whenever we declare a array, whenever we declare a pointer, a structure, a file, definitely they will consume some kind of memory, some sort of memory into your computer, because inside those memory locations only we are going to put the data and we are going to manipulate the data, isn't it? So that data, whatever we are keeping inside the memory location, in order to access the data, we are having only one reference, that is the address of that memory location. So using that address, we can access the memory location, but that is not the suitable way. So what is the suitable way, or how we can access the memory location in the sense by giving it a proper name? Okay. So if you don't have a name given to the memory location, then the only way is with the help of address you have to access that memory location. But accessing the memory location with the help of address, that is not the proper way. That is not the what we call the easiest way. So in order to access the memory location, or in order to do the manipulation, on that memory location, definitely we need to depend on the name, okay, a symbolic name given to the memory location, and that symbolic name is nothing but your identifier. Identifiers are nothing but symbolic names given to the memory locations. Okay, without the memory location, I mean without the symbolic names, how we can access means with the help of addresses. And accessing the memory locations with the help of addresses, it is a very difficult job, it is a tedious job, it is not an easy job. So how we can access the memory location instead of going with the addresses, how we are accessing means we are giving some symbolic names to it, and with the help of those symbolic names we are accessing the memory location. Remember this one. Identifiers are helpful in naming the objects in C language, and using those symbolic names only we can access the memory locations inside your C language. And without, I mean if there is no concept of identifiers, how we can access the memory locations in the sense with the help of memory addresses. Only these things you have to remember over here. Okay, identifiers are similar to nouns in natural languages, and without the identifiers we cannot access the memory locations where we are storing the data. And if there are no symbolic names or if there are no identifiers given to the memory locations, then the only way to access those memory locations is with the help of their addresses, unique addresses. And as remembering the addresses and accessing the memory locations with the help of addresses, it is not the ideal way, so we are going for symbolic names or we are going for identifiers. And you cannot simply give any random name to your memory location, or you cannot simply give any random name to your object. You must follow some rules. Okay, some rules when you are giving the name to your memory location. Okay, so what are those rules? In the sense you have to follow only 4 points over here. Under rules you have to follow only 4 points or 4 different rules for framing the identifier. It is also an important question. Okay, the entire identifiers concept is an important question for 2 marks. Okay, what is an identifier? You have to write the definition, and what are the rules for framing the identifier? You have to write these 4 points. Okay, so maybe this question will come into your mid exams. I cannot say. Okay, definitely it is going to be in your important questions. Okay, there are some rules while framing the identifiers, and what are those rules? In the sense, the first rule, the first character, when you are giving the name, the first character must be an alphabetic character. It cannot be an underscore. Oh, sorry, it cannot be a digit. See, when you are giving the name, let us say I am giving the name as amount. Okay, amount, A-M-O-U-N-T, amount. So like this only you have to give. The first character must be either an alphabet or an underscore. Like this also you can give underscore amount, also you can give, but like this you can't give 9,000 amount. Like this you can't give 9,000 amount. Like this you can't give. The reason for this, the first character here, you can see the first 4 characters, they are digits. So digits are not allowed as the first character into your identifier name. The first character must be an alphabet or an underscore. No other character is allowed. Okay, so the second point you read, it must contain only alphabet characters, digits and underscore. No other special character is allowed. Like when you are giving the identifier, when you are giving the name to your object, you cannot use the $sign, you cannot use the asterisk sign, you cannot use the cap, you cannot use the slashes, single quotes, double quotes. Like this you cannot use any other special characters. What are allowed? In the sense, alphabetic characters. Alphabetic characters in the sense capital A to capital Z, small a to small z, they are alphabetic characters. Then digits in the sense 0 to 9. Okay, then underscore symbol. Only these things are allowed when you are giving the identifier. Rest of all the special characters which are there, like your brackets, curly bracket, square bracket, parenthesis, angular bracket, all these things are also not allowed when you are framing the identifiers. What are allowed I told you, and what are not allowed, that also I told you. Only the alphabetic characters, that is small a to capital Z, small a to capital A to capital Z, small a to small z, and digits 0 to 9, and underscore symbol. Only these things are allowed when you are framing the identifier. No other special character is allowed. And the length, the third point, if you read the length of the identifier, it will be up to 63 characters only. Okay, only the first 63 characters of an identifier are significant. That means how much length you can give, I mean how many characters you can give inside the identifier, in the sense up to 63 characters. If you give the 64th character, your compiler will not generate any issue, but it will simply ignore that 64th character. Not only 64, afterwards whatever, how many characters you give, it will consider only the first 63, and rest of them it will simply ignore. Remember this one. 63, only the first 63 characters are significant when while naming the identifier. And the last point, the fourth point, your identifier, it should not be a keyword. You cannot use a keyword as an identifier. The four important points, the four important rules when we are framing the identifier are these ones only. The first character, it must be a alphabet or underscore. The digit is not allowed as the first character, and it must contain only alphabets, digits, and underscore symbol. Other special type of symbols are not allowed. Then only the first 63 characters are significant. That means if you give more characters, I mean more length to your identifier, more than 63 characters, it will simply ignore the rest of the characters and it will consider only the first 63. And your identifier, it should not be a keyword. Okay, what are keywords and how they are important in C language, that we will discuss in our next slide. Okay, uh, yeah, this is about keywords. So these keywords, they are like reserved words. So let us assume we are in English language, we are naming something. We are naming something. Okay, a new object has came and you want to name it. Okay, like let us assume you want to give a person's name. A person's name, because for persons you can give any random name, isn't it? Okay, you can give any random name, but there are some fixed names that you can't use when naming the persons. Okay, like some place names, like we have Hyderabad, Secunderabad. We have some monument names like Charminar, Qutub Minar. Likewise we have some monument names, and Taj Mahal. And we have country names like India, Pakistan, Bangladesh. Like this, we have some fixed names. So these names we can't give to persons, isn't it? Okay, a new person has came and you want to give a new name to him. Can't Can you give like Taj Mahal the name to him? No, it is not. Okay, of course it will to some extent it will not give any vulnerability, but in practice it is not allowed, isn't it? So in that same way, in C language also we have some fixed words, we have some reserved words. They're having some fixed meaning in your C language, and because of that reason, as they have some fixed meaning, because of that reason we can't use these keywords as identifiers. Okay, identifiers will be random names, but keywords, they are fixed, they are reserved, and they are having some special meaning. Okay, and when you use these keywords into your C language, they will exhibit, they will give that meaning. Okay, so keywords are also known as reserved words. They are syntactical tokens which have special meaning when used in programming. Keywords can't be used as identifiers for variables, functions, and named constants in programming. In C language, we have around 37 keywords. So simply you remember these 37 keywords and you understand the meaning of these 37 keywords. You almost learn 70% of the C language if you understand the meaning of these 37 keywords. Okay, so those 37 keywords, they are listed over here. You can see the uh, yeah, they kept like alphabetical order, but when we go through around these keywords according to their priority or according to their importance in C language we will study. But in this table they kept all these keywords, they kept in alphabetical order, as you can see. So first we have auto, then break, character, constant, default, double, enumeration, extern, for, if, inline, long, restrict, short, size of, struct, type, def, unsigned, volatile, boolean, case, complex, continue, do, else, float, go to, imaginary, int, register, return, signed, static, switch, union, void, while. So all these keywords, whatever we are seeing in this table, they are having some special meaning in your C language. When you use these keywords into your C language program, they will exhibit their meaning over there. Okay, they will give their meaning over there. So because of that reason, you can't simply name any of the variable with these keywords. So that means you can't use these keywords as identifiers in your C program. Hopefully you understood. So the next concept, we have the types, and then we have the variables that we will see in our next session, hopefully. Okay, so after this video, when you successfully complete this video, you will be given with one small assignment type of thing that you need to fulfill, and with that fulfillment only I will consider your attendance. So be ready for that one. And moreover, um, nevertheless, very soon we are going to have your internals, and you need to be ready. I mean, whatever concepts we complete till that internal, I will consider all those concepts as important concepts for your internal. Okay, bother about it. Definitely you need to bother about it. You need to start the preparation as early as possible. uh, Definitely I will give the important questions that I'm going to ask in internals, and you can do the preparation accordingly. Okay, thank you very much, students.